The second order attack, you inject data or objects into the database. That will prepare the database to be hacked later. So 2 stages. Now, why might this happen? Perhaps you've outsourced your software development. If you outsource your software development, you have no idea who is writing your software. And if you outsource your software development to skill builders, we don't make a habit of employing criminals. I wouldn't like to speak for some other people, though. No, you've no idea who's writing your code. And it is horrifyingly easy for malicious developers to construct time bombs, which maybe will fire later on. You might be they might not have much in the way of privileges, but there may well be techniques they could use to set things up for an exploit later. Because, of course, once the code is written, it's assumed to be trusted. For example, crafted object names, functions the same name as columns. Unusual table names, think of double quotes and lowercase letters and things. Table names that look the same could actually be different. Or views or synonyms to do redirections. I'll do a very simple example here, because I'm always wary of time. But what I shall do at this point, a second order attack, remember, it doesn't immediately result in the breach. It prepares the system for the security breach in future. The entry point will be a trusted source. A user or developer has legitimate access to the system. I saw an application the other day where the whole application consisted of SQL statements that were prepared and stored in a table. If you have access to that table, of course, you can trick people into running anything you want. I'm going to demonstrate perhaps a slightly more clever example. A simple example would be a developer who has the ability to drop and create objects out of schemas. So what shall I do? I'm going to create a user to set this up. I'll create a user called apps. I've chosen apps because I mentioned eBusiness Suite earlier. I used to do a lot of work with eBiz, not so much now. In the eBiz environment, there's a user called apps, and apps has total power. Apps can do anything in the database. And no one should ever log on as user apps directly. You're always protected. Apps is always protected by the application code. And the app's password is deeply hidden. So no one should ever log on directly as apps. But apps is very powerful indeed. So to simulate that environment, I shall quite simply grant all privileges to apps. This is a common model, one user with total power, to which nobody logs on correctly. Now I'll create my malicious developer, and I'll call him after myself, JW. Create my developer, JW, and give him the privileges he needs to do his job. Obviously, I'm constructing this example, so it is a bit artificial, but I'm going to give him create session so he can log on, create procedure so he can write code, and I'm going to give him create any view. Perhaps part of his job is to make life easier for other users by constructing views that do complex denormalizations for other users. That happens quite frequently. So he's going to create any view as well. Well, these privileges on the face of it perhaps don't look too dangerous. So if I connect as him, what can I do? Select star from session roles. I've got no roles. And if I look at my system privileges, that's all I've got. That looks fairly safe. It isn't. So what I'll do is several stages here. First off, I'm going to create a function. I'll walk through the code shortly. So I'm creating a function, and I'm going to grant execute on that function to public. So look at what this code does. Create a replace function F1, return varchar2. Auth ID current user, that's important. This is invokers rights code. Now, the PL SQL security model, you have invokers rights and definers rights. The default model of definers rights code means the code will run with the privileges of the developer. What I have highlighted here is invokers rights code. The code will run with the privileges of whoever runs it. So that's in one sentence is the difference between definers rights and invokers rights. It's all to do with privilege escalation. Can you acquire privileges that belong to someone else? And in this case, my developer, JW, will be able to escalate his privileges to those of whoever is running it. That's why that's going to work. If my developer tries to grant himself DBA, so grant DBA to myself, no way. This is different because it's going to run with the privileges of whoever invokes F1. Well, of course, user apps isn't going to run my procedure F1. He isn't a complete idiot. He doesn't even know the procedure F1 exists. So I've got to fool him into doing it. What I shall do is create a view. Create a replace view, apps.dual. Well, we all know what dual is, don't we? Apps.dual. And my view apps.dual is select JWF1 dummy from all users, where onum equals 1. So I've created a view in the app schema, which I've got privilege to do. And what that view is going to do is run that function. Think of the dual table. And here I am as user JW. If I select star from dual, I get back X. And we do this sort of thing all the time. Every application is going to select from dual. So at some point in the not too distant future, my application running under apps is going to do this. And he gets back an uppercase X. Just what did he query? If I go back as JW, well, previously, I had no roles. Let's see what I've got now. I've got the lot. So, simple example of a second order attack. I've injected the object, the view, into a highly privileged schema. Then it's just a matter of time until the exploit is complete. So that's your second order attack. In my case, I used a view to redirect to a different object. And of course, once I've got that, I'll promptly delete the view. Okay, that should have frightened everybody a bit, but it gets worse.